Imagine standing in your backyard on a summer morning, looking at two tomato beds planted on the exact same day, with the exact same seeds, the exact same soil, the exact same water, the exact same fertilizer. Everything identical. Except for one thing. In the bed on the left, there is a small copper wire twisted into a spiral, pushed into the ground next to the plant stem. And, after 30 days, that bed on the left is producing more fruit, with visibly healthier, deeper green plants. This is not a story I heard from someone on the internet. This is something I did myself, measured myself, and recorded every single day for 30 days. Over 10 million people on TikTok are doing this right now, and they swear their plants are growing twice as fast, sometimes 3 times. They call it electroculture. And these are not random people. These are serious gardeners, homesteaders, families who have been growing their own food for decades. Their videos rack up millions of views. The comments are full of things like "it actually works" or "my garden has never looked this good in my life." But here is what I need to tell you straight up, right now, before we go any further. I did not make this video to sell you a copper wire kit. I also did not make this video to tell you that 10 million people are all wrong. I made this video because I genuinely wanted to know the truth. And the truth I found after 30 days of testing, combined with hours of reading peer-reviewed science, is more complicated and honestly more fascinating than any 60-second TikTok clip could ever tell you. The copper wire bed did outperform the control. But the reason why, that is the real story. And that story does not start on TikTok. It starts with a French scientist in 1746 who observed the exact same thing and also could not explain it. In this video, I'm going to take you through the whole journey. The real history of electroculture that no social media video has ever actually told, what the science genuinely proves and what it does not, the full 30-day results with real numbers, and what I believe is actually driving plant growth in your garden, backed by science you can start using today. If this is your first time on this channel, I run experiments like this regularly. No hype, no sponsorships pushing an agenda, just real results. Hit subscribe so you do not miss what comes next. Before we get into my experiment results, I need to take you somewhere most people never go when they talk about electroculture. Because here is the thing that blew my mind when I started digging into this. Electroculture is not a TikTok trend. It is not something some guy in his backyard invented 3 years ago. Electroculture is older than the United States of America, and the story of how it disappeared and came back is one of the most fascinating rabbit holes I have ever fallen into. Let me take you back to 1746. A French physicist named John Nollet was running experiments with early static electricity machines, giant glass wheels spinning against silk pads, throwing off sparks. And almost by accident, he noticed that seeds placed near these machines germinated faster. Noticeably faster. He published his findings, the scientific community moved on, but the seed of curiosity had been planted. A few decades later, a scientist named Peter Berthelot noticed that fields hit by lightning storms produced more robust, greener crops in the weeks that followed. He spent years studying it and wrote an entire book on what he called atmospheric electricity and plant growth. He was right that something was happening. He just had the wrong explanation for why. And I will come back to that in a few minutes, because the real reason is the most surprising thing in this entire video. By the early 1900s, electroculture had become a serious scientific movement. In 1900, a scientific society in St. Petersburg confirmed that low-voltage electrical stimulation had measurable effects on plant growth. In 1912, there was an international conference in France dedicated entirely to electroculture. And in 1918, the British government formed an official electroculture committee to study it. That is not a fringe movement. That is mainstream science taking something seriously. Then chemical fertilizers arrived. Cheap, consistent, and easy to measure. The inconsistent results of electroculture experiments could not compete, funding dried up, and the whole field went dormant for almost a century. Then, in 2022, a wave of homesteading content hit TikTok right as millions of people were rethinking their relationship with food after the pandemic. Someone posted copper wire spirals in a garden bed. It went viral. And just like that, a 300-year-old idea was suddenly on the For You page of people who had never heard of John Nollet in their lives. Now, here is where it gets really interesting. The question is not just whether electroculture works. The question is why some people genuinely seem to get results, and whether the explanation has anything to do with copper wire at all. So, let us look at what the science actually says. Plants and electricity do have a real relationship. When an insect bites into a leaf, the plant sends electrical signals down through its stem, triggering other leaves to produce defensive compounds before the insect even reaches them. This electrical signaling in plants is established biology, documented in peer-reviewed journals for decades. So the foundational idea that electricity and plant biology are connected is real science. Researchers have run controlled lab experiments applying low-voltage electrical fields to soil and root systems, and some have shown yield increases of 10 to 30%. But here is the critical detail that the TikTok version of electroculture completely ignores. Every single one of those promising studies used active electrical stimulation, meaning a controlled power source with calibrated voltage levels. A copper wire spiral pushed into your garden bed is passive electroculture. There is no power source. There is no calibrated voltage. There is just a piece of copper metal sitting in dirt. Researchers at Washington State University concluded that the claims of passive electroculture proponents are not supported by reliable scientific evidence. A 2025 study published in a peer-reviewed journal called PLOS One tested passive electroculture directly and found no consistent evidence that it improves crop yield. The voltages required to actually stimulate plant cells are far beyond what a copper stake in soil could ever produce. So why are millions of people saying their gardens improved? The answer goes back to Peter Bertillon and those fields that thrived after lightning storms. Here is what he did not know. When lightning strikes, the extreme heat tears apart nitrogen molecules in the atmosphere. Those nitrogen atoms then combine with oxygen, dissolve into rainwater, and fall to the ground as nitrate, a form of nitrogen that plant roots can absorb immediately. Scientists estimate that lightning fixes between 5 and 8% of all natural nitrogen entering soil globally every year. Think about what that means for a gardener running an electroculture experiment in summer, which is peak thunderstorm season across most of the United States. Every time a storm rolls through, both garden beds, the one with copper and the one without, receive a free dose of nitrogen fertilizer straight from the sky. The plants surge, and the gardener credits the copper wire. That is the twist. That is the thing nobody on TikTok is telling you. Now let me walk you through exactly what happened in my own experiment, week by week, with the real numbers. Both beds were large containers with the same organic potting mix, the same heirloom cherry tomato seedlings from the same seed packet, the same watering schedule, the same fertilizer. Bed A had 3 copper wire spirals wound in a Fibonacci pattern and pushed about 6 inches into the soil. Bed B had nothing added. Week 1 showed almost no difference. By day 7, bed A was 12.3 inches tall and bed B was 12.1 inches. That is less than 2% variation, well within the normal range between 2 plants from the same seed packet. Leaf counts were identical at 8 each. The soil felt the same in both beds every morning. I will be honest with you, by the end of week 1, I was starting to wonder whether the next 3 weeks were going to give me anything worth talking about. But I kept measuring, because that is what a real experiment demands. Week 2 brought the first hint of something. Bed A reached 24.7 inches, while Bed B was at 23.9 inches. Still a small gap, but it was starting to feel consistent. Bed A had 3 flower buds forming versus 2 in Bed B. Not enough to draw conclusions, but enough to make me pay closer attention. The weather that week was warm and sunny with no significant storms, which I noted carefully in my records. Then came week 3, and this is where things got genuinely fascinating. Both beds exploded with growth. Bed A grew 31% taller compared to the previous week. Bed B grew 28%. By day 21, Bed A had 11 flowers, and Bed B had 9. On the surface, it looked like the copper bed was pulling ahead. But when I checked my weather records, I saw something that stopped me cold. We had 3 significant thunderstorms roll through that week. 3 nights of lightning and heavy rain. And both beds surged together, not just the copper bed. The timing matched those storms perfectly. Week 4 brought harvest day and the final numbers. Bed A, the electroculture bed, produced 347 grams of tomatoes across 23 fruits. Bed B, the control bed, produced 318 grams across 21 fruits. That is a 9.1% difference by weight and 9.5% by fruit count. Bed A won. There is no way around that. But a single experiment with 2 beds cannot tell us whether copper wire caused that difference. To make a statistically meaningful claim, you would need to run the same experiment at least 5 to 10 times under varied conditions. What I have is one data point. And one data point cannot tell you whether that 9.1% came from the copper spirals, from a slightly different sun angle, from one extra splash of water in week 2, or from 3 thunderstorms delivering atmospheric nitrogen to both beds equally, while one of them was already performing slightly better for reasons that had nothing to do with electroculture. That is what real science feels like. Uncertain. Demanding more questions rather than delivering easy answers. Here is what I can tell you with confidence. The most dramatic growth in both beds happened the same week as the biggest storms. The copper bed won by 9%. And I cannot tell you why. What I can tell you is what science has proven actually drives plant yield. And this is the part most people skip because it is less exciting than copper wire but delivers results every single time. The single most important factor is soil biology, not fertilizer numbers. The living ecosystem of microorganisms in your soil. Long-term studies through the University of California Agricultural Extension Program have shown that gardens with high-quality compost outperform those using synthetic fertilizers alone by 40 to 60% across multiple growing seasons. Compost feeds the biology feeds the plants, and that system compounds over time in ways no single product ever can. Kitchen scraps, cardboard, dried leaves, grass clippings. That is all you need. A backyard compost pile will do more for your garden than any kit you could order online. The second factor is companion planting. Research from the University of Florida found that planting basil alongside tomatoes measurably reduced aphid and thrips populations. Marigolds around vegetable beds reduce soil nematodes through compounds from their roots. Dill and fennel attract predatory insects that feed on common pests. No extra cost beyond a few seed packets, and the results are replicated consistently enough to appear in agricultural extension recommendations from universities across the country. The third factor is watering technique. Most people water frequently and shallowly, which keeps roots close to the surface and makes plants vulnerable to heat and drought. Research from the University of California at Davis found that deep, infrequent watering produced root systems 40 to 60% deeper on average, with significantly more resilient and productive plants across an entire season. Water less often, but water thoroughly. Add a 3 to 4 inch layer of organic mulch around your plants, and you can cut your water use by 30 to 40% while actually improving conditions for the roots. And here is what I genuinely believe connects all of this back to electroculture. When someone starts the practice and their garden improves, they are not imagining it. But what changed is not the copper. What changed is that they started paying attention. They visit the bed more often. They notice problems earlier. They pull weeds more carefully while inserting the stakes. That attention, that relationship with the soil, is what grows the food. The copper wire is the ritual that brought them there. So here is my honest verdict, after 30 days of data and 300 years of history. The copper wire bed won by 9.1%. Those numbers are real. But, the science says, passive electroculture has not been shown to reliably drive that kind of result in controlled conditions, and long-term copper accumulation in small garden beds is worth thinking about seriously. At the same time, the electroculture movement has brought millions of people back to their gardens. It has made people slow down, get their hands in the soil, and care about something living and growing. In a world where most people have never watched a seed become a fruit, that matters. If you want to try electroculture, try it. The cost is low and the risk is minimal. Just do not let it replace the things that science knows actually work. Feed your soil biology with compost. Use companion planting. Water deeply and mulch well. Those 3 practices alone will transform your garden more reliably than any trend ever could. Now I want to hear from you. Have you tried electroculture? What did you grow? And what did you see? Leave it in the comments below. I read every single one, and I will be responding for the next 48 hours. If you want to see whether coffee grounds are actually worth the hype or just an overhyped mistake, subscribe right now, because that video is coming, and I promise the results will surprise you just as much as these did. Thank you for spending this time with me. Keep growing, keep questioning, and I will see you in the next one.